Going to the next. So what we are taking today, industry example is a aviation fueling system. All of us travel by flights. We all know that at the airport flights get refueled, meaning uh, fuel which is required for the flight is fueled at the airport in the parking. So for that there is a system. Okay, it is called aviation fuel form, and the system consists of five. Let's say this is a typical big airport system. Okay, so this is there are five product transfer pumps. Now product means the flight fuel, aviation fuel, which is coming by the tankers. The tankers will push this product through this product transfer pumps to the storage tanks. In between the storage tanks there are microfilters and there are filter water separators. Now, filter water separators and microfilters have a function which we will come to it little bit later. Then there are three product tanks in which the tanks are in which the storage of the product is done before it goes to the flights. Then there are four hydrant pumps. Now, hydrant means it's a long pipeline from product tanks to the flight. Usually, now in this particular case, which I have taken, the pipeline or the hydrant is 11-kilometer long. So you can imagine the product has to be transferred by through pumps 11 kilometers all the way to the last flight. Now, if you come to the parking lots, the parking lot is of 150 flights can be parked. So there might be five flights which are fueling, there might be 10, there might be 20, 30, 40, multiple flights, or there may not be any flight which is actually fueling. So those different situations will come and the instrumentation requirement comes up because of this variation or the dynamic condition of the flights. So what are the main mandatory requirements? Okay, when you say aviation fuel, the fuel which is going into the flight, the fuel should be completely free of dirt or sedimentation. Then there should not be any moisture or water content in the fuel. Quality of product, reliability of the entire system, because when you are fueling a flight, it should be done within a particular time period. If you don't fuel the flight within the time period, there are a lot of penalties and they are hefty. They are huge penalties. So system has to be very reliable and it should be very efficient. We will come one by one and see how these all these mandatory requirements are addressed. In addition, what are the controls that we put in one by one. But for a moment, on while we are on this slide, let's understand it's a very simple system. There are five product transfer pumps. From the tankers, product is coming into the tank. From there, it is pumped out to the flight. Very simple system. But now you will see how the complications are getting addressed. So when you come, the first thing, when I said the first thing is microfilters, right? So microfilters are required because the tankers and the pipeline, you imagine the fuel is coming from the refinery through some pipeline, through some tankers, then it is coming to this fuel farm. So all the way there can be rusting, there could be microparticles which are there in the fuel and those are to be eliminated. So first, when you are putting the tanker product into the tank, you have microfilters. The green arrow shows there are two microfilters which will actually take out all the sedimentation and dirt which has come. Then next is filter water separators, because you have to also eliminate entire moisture or water. Even a small droplet is not acceptable. So you remove complete dirt, complete sedimentation, complete moisture or water content in the fuel. So for that purpose, you have microfilters in the beginning itself, then you have filter water separators, and then when you are pumping the product out from the tanks, you again have filter water separators. Now, you also know that how, let's say this is a process, all the pipelines are there, pumps are running, product is being pumped. But microfilters can get choked, right? Because the dirt and sedimentation is coming. How will you know the filters are choked? So for that, first instrumentation we'll put is differential pressure transmitters across input and output of the microfilters. So as the differential pressure keeps rising, you know that the filters are choked and they need to be serviced. Same thing you will do with filter water separators, where water is separated at the same time whatever remaining particles of dust, dirt and sedimentation are there are also removed. So on the top also, on the water filters, you will put differential pressure transmitter and on the microfilters. So these will be connected to the control room, and in the control room you will have indication that the microfilters or the filter water separators are choked and it's high time to clean them. The next part of this is the product inventory control. Okay, so when you are pumping the product from the tankers into the tank, you also need to know how much product is there in the tank. So for that purpose, you will have level transmitter. Usually radar kind of level transmitters are used because they are very accurate, and as a redundancy, because this is a critical thing that you need to know how much product is in the tank. You will also have a redundancy in terms of float and tape, which is a very simple device. You have a float and it keeps, the name itself suggests that it keeps floating on the product and it gives you indication of the level of the product. Same thing is done in the radar. In some other course, we will talk about different type of level transmitters and how they work and function. But for the purpose of this module, please remember you have one radar type and we have as a redundancy one float and tape type, which is not but it still gives you still can see the other one. That is one of the principle is that in the critical cases or the critical product parameters, you will always have two instruments. You will see if one fails, the other one is still available for you. So that is the tank inventory. Now, why inventory? Actually, you are measuring level, but since you know the tank dimensions, from the dimensions and from level, you can calculate in PLC automatically the inventory in terms of how many liters of the product is available in the tank. At any point in time, you can continuously read it. This is about the tank inventory. So we have now, first we added differential pressure transmitters. Now we have added tank level inventory, level transmitters. All these green arrows where I have shown are the level transmitters on the tank, on the top of the tank. Now go next level. Even though if you have two level transmitters, still you want to ensure the tank never overflows, or when you draw the product from the tank, it does not go empty. So what you do, you put level switches, one at the high level and one at the low level. These level switches are connected in the interlock system, wherein if the high level comes, the product transfer pumps from the tankers will stop and will not pump more product into the tank because already tank has reached high level. And the hydrant pumps, which are pumping the product from the tank to the flight, will stop in case of low level so that they don't run dry. So I'm sure this is very clear because where I'm showing the arrows are the level switches. High and low level switches are put. This is mainly for the safety purpose, because even if you have radar transmitters, float and tape type level transmitter, you still want to ensure that safety is maintained, that tank does not overflow or does not go dry and the pump does not go dry. Okay, so we'll move to the next. There is also underground storage tank in which the product which is from the filter water separators bottom, like as I told you, the filter water separator will separate water and the product will move up. So whatever little moisture or water gets collected in the filter water separator at the bottom is drained into the underground storage tank, and whenever that high level reaches, that will be pumped out to for the further processing. So these two level switches are also shown. The green arrow which is shown on the underground storage tank. Also, there are two level switches for safety. Now let's move to the next. Okay, so now there are three tanks and four product pumps plus five product transfer pumps. So you by this time you would have understood that you cannot pump product to any tank. You cannot just take delivery from any tank. All of that, there is also a interlock system. But to understand that, we will take a little bit next slide. But before that, you remember that we are now doing control of inlet and outlet tank. Each tank inlet and outlet we want to control from remote. That is why we put motorized operated valve, motor operated valve they call MOVs, where the green arrows are shown. So on each tank, one is the receipt, that is the product coming into the tank. The other one on the top of it is a recirculation. So say on the hydrant, you are pumping the product, and if suddenly one flight stops, it is full, and the product is recirculated into the hydrant, it will come back to this recirculation line and go back to the tank. So on each tank, there is one inlet, one recirculation, and one outlet. From outlet, it will go to the product transfer pump, hydrant pump, and then go to the flight. So these walls are very important, and the big walls, therefore, we put MOVs and connect them to PLC so that you can control them in sequence. Why they have to be controlled in sequence? For the purpose right now, we just remember that we have now put control on these walls in terms of motor operated walls, which can be operated from remotely, in our case, from the control room.